All right, so let's implement counting sort. Once again, I've created a project. I've got the code in package academy.learnprogramming.counting sort, and I'm going to write a method called counting sort. So I'll say public static void counting sort, and we're going to accept the input array and the minimum value in the range and the maximum value in the range. Remember that counting sort assumes that all of the values fall within the range min to max. So the first thing we're going to do is to create the counting array, the array that's going to keep track of the count. So we'll say int count array, and this array has to be large enough to be able to count each possible value. And so we're going to say new int, and we want it to be max minus min plus 1 in length. If our minimum is 1 and our maximum is 10, which is what we're going to pass in, then we're going to create an array of length 10 minus 1, which is 9, plus 1, which is 10. And that's what we want because we have a possible 10 values, 1 to 10 inclusive. So once we've created our count array, what do we want to do? Well, we want to traverse our input array, and here's our input array up here. It's not our usual array. It's the array that we went through in the slides. And so we're going to traverse this array, and we're going to count how many of each value we have. And so we're going to say for int I equals 0, I less than input.length, I plus plus, and we're going to say count array, and the way that we figure out where each value is counted is we say input I minus min. That's going to be the index of where to count each value. So for example, let's say input I is equal to 5. So let's say we're at the point where we're counting this one. Well, to figure out which element we should increment in the count array, we would say 5 minus 1 because that's our minimum, and so we'd increment count array 4. Because remember, we could have values, let's say, going from 10 to 20. And in that case, the count array would be 11 elements long. And so we need to translate the values 10 to 20 to indices 0 to 10. And that's what we're doing here. And we can do that just by subtracting out the minimum from whatever value we're counting. And so to count ones, if we got a 1, we'd subtract 1 minus 1. So we'd increment element 0. If we got a 2, 2 minus min is 1, and so we'd increment element 1. If we got a 10, 10 minus 1 is 9, and we'd increment element 9 in the count array. And so all this is doing is translating the value we want to count into its index in the count array. And what do we want to do? Well, we want to increment that position. And so that's all we do here. So this is the counting phase. That's all it involves. We go through each element in the array, we look at the value, we figure out where we're counting that value in the count array, and we increment that value by 1. So once we finish counting, we now want to write the values back into the input array. So we're going to say int j equals 0, and then for int I equals min, I less than or equal to max, I plus plus. So what are we doing here? Well, j is the index we're going to use to write to the input array. And I is the index that we're going to use to traverse the count array. Now we're setting I to min and I less than or equal to max because, as you'll see, because we're doing it this way, we can just write the value of I back to the input array on each iteration. So inside the loop, we're going to say while count array I minus min is greater than 0. And you'll see why in a minute. Let me write the rest of the code. So we'll say input j plus plus equals I, and count array I minus min minus minus. Okay, so what's going on here? What we're doing here is remember that each element in the count array has a count, and that count can be greater than 1. So let's go through this for the number of 2's, because we know we have 2 2's in our array, and the count of 2's is kept in count array 1. So when I is 2, we say while count array 2 minus 1, which is count array 1, is greater than 0, we want to keep writing 2's to the input array, because at this point we're writing the number of 2's. And so the first thing we do is we write a 2 to the input array, and then we need to decrement the count. We've already written 1 2, and so we only have another 2 left to write. And so we started with count array 1 equals 2 because we have 2 2's. We write one of the 2's to the input array, and then we decrement the count to 1 because we only have 1 2 remaining. We loop around. Count array 1 is still greater than 0, so we're going to write another 2, and then we're going to decrement the count again. And at this point, the count will be 0 because we've written both of the 2's back to the input array. And so when we loop back around, at this point, count array 1 will be equal to 0, and we drop out of the loop. And then I will be incremented to 3, and we enter this loop to write the number of 3's. And once again, each time we write a 3, I don't believe we have any. Oh, we do, one at the end. So each time we write a 3, the count will be decremented by 1 until we've written all the 3's, and then we'll loop around and we'll write the 4's. So we've written the loop this way, starting I at min, because then we can just, when we're writing out the number of 1's, I will be 1. When we're writing out the number of 2's, I will be 2. So we can just stick I in and subtract here. We could have started I at 0, but then we'd need to do a different type of calculation. Here, we'd need to figure out what value we're writing. So I think it's clearer to set I to min, because then we know that on the first iteration we're writing out 1, the second iteration we're writing the 2's, the third iteration we're writing the 3's, etc. And of course, J is keeping track of where we are in the input array. So this is a fairly straightforward algorithm, I would say. If you're having trouble understanding it, you can go and check the slides. But of course, we want to see if it works. So let's call counting sort, and we'll call it with int array. Our minimum value is 1 and our maximum value is 10. So let's go ahead and run. And here we go. 2, 2, 3, 4, 5, 7, 8, 8, 9, and 10. Exactly what we expect. And so that's counting sort. And once again, this algorithm is only good to use under specific circumstances. You only want to use it when the range of values is reasonable, meaning it's not too large, and the data set is a reasonable size as well. So ideally, the number of unique values, or the range, won't be significantly greater than the number of items you want to sort. So as I said earlier, if you have an array of length 10 and it can hold values from 1 to 1,000,000, that's not a good candidate for counting sort, because you're going to have to create a counting array of length 1,000,000 to sort 10 items, and obviously that wouldn't be a very good idea. I'll see you in the next video.